Let's talk about the secret lives of molecules. We're going to answer a pretty simple question. What gives them their unique personalities? And you'll see, it's a concept that explains everything from the sour kick of vinegar to the clean feel of hand sanitizer. Trust me, it's way cooler than it sounds.
So, let's start with a little riddle. What in the world could a bottle of vinegar, that sharp-smelling stuff in your kitchen, have in common with the hand sanitizer you've been using all the time? I mean, they look, smell, and feel completely different. But chemically, they're actually surprisingly close cousins.
The secret here isn't in their main structure, what a chemist would call the carbon backbone. Nope. The real game changer is this tiny, super powerful attachment. Think of it like a molecular identity badge. This one little addition dictates everything about how that molecule is going to act. And figuring that out is the key to this whole explainer.
Okay, so to really get a handle on these identity badges, we first need to look at the blank canvas they get attached to. And that brings us to the world of carbon backbones. Let's start with something really basic, like propane. It's just a simple chain of 3 carbon atoms, and all the empty spots are filled up with hydrogen atoms. You can think of it as a plain, undecorated skeleton. This is our blank canvas.
Now, chemists call these simple chains saturated hydrocarbons. Saturated is just a fancy way of saying they're totally full of hydrogen atoms. And yeah, they're very stable, which is great, but let's be honest, they're a little boring. They don't have much of a chemical personality on their own. But that is all about to change.
And this is where the fun really starts. We're about to give these plain Jane molecules a complete makeover, all by adding one of those special identity badges.
So, this identity badge we keep talking about? In chemistry, it has an official name, a functional group. All it is really is an atom, or maybe a small group of atoms that just swaps places with a hydrogen. But here's the wild part. As soon as it's attached, it decides the molecule's new identity and what it can do. It doesn't matter if the carbon chain is long or short. This new piece is the boss.
The whole process is kind of like building with chemical Legos. You start with your plain chain, you pop off a hydrogen, and you snap on a new piece, the functional group. And just like that, you've got a totally new compound with a whole new personality and a brand new set of superpowers.
Okay, let's make this real with our first case study, the alcohol group. This is the identity badge that's going to give us our hand sanitizer. And here it is. The alcohol functional group is so simple it's almost deceptive. It's just one oxygen bonded to one hydrogen, or OH. But don't let its tiny size fool you. This little attachment is about to do some serious chemical work. All right, so imagine we take a simple 2-carbon chain. That's called ethane. We swap out one of its hydrogens for this OH badge, and boom, we have just created a brand new molecule, ethanol. And yes, this is the exact same alcohol that's in hand sanitizers and alcoholic drinks. And believe me, this personality change is huge. That little OH group makes ethanol an amazing solvent. It introduces a kind of molecular magnetism that lets it dissolve things that other chemicals can't touch. It also makes it love water, so it's completely soluble. And that's exactly why it's so useful in things like cough syrups, and, of course, as the power behind sanitizers. A completely new identity, all thanks to one tiny badge.
Okay, you ready for the next identity badge? Let's see how this works again. This is the one that's going to give us vinegar.
So this badge is a little more complex. It's called the carboxylic acid group, or COOH. You can see it has a carbon double bonded to one oxygen and then single bonded to another OH group. This very specific structure is the key to its unique personality. So let's grab that same 2-carbon chain we used before, but this time when we attach the COOH badge, we get a totally different molecule called ethanoic acid. Same backbone as our ethanol, but a completely different personality is about to show up.
And what a personality it is. That COOH group makes the whole molecule acidic. In fact, ethanoic acid is really just the formal name for what most of us just call acetic acid, and a little 5 to 8% solution of this stuff in water? Yep, that's the vinegar sitting in your pantry. We went from a boring hydrocarbon to a key ingredient in salad dressing just by changing the badge. So, we've seen that the type of badge you use matters a lot, but what about where you put it on the chain? Well, it turns out in chemistry, location is everything.
Let's look at 2 new molecular families, aldehydes and ketones. Now, they both share a core part of their identity badge, a carbon double bonded to an oxygen. But here is the crucial difference. In an aldehyde, that badge is always stuck at the very end of the carbon chain. In a ketone, it's always found somewhere in the middle. You can really see the difference here, right? See how the aldehyde group has that hydrogen attached? That forces it to be at the end of the line. The ketone group, though, it's designed to be sandwiched right between other carbon atoms. It's such a subtle little structural difference, but it has massive consequences.
And that one little difference in placement, it's not just a minor detail. It creates two entirely separate families of molecules. Aldehydes and ketones react differently, they smell differently, and they have completely unique jobs in chemistry and biology. It's just a fantastic example of how precise and, honestly, how cool the rules of chemistry really are.
All right, let's do a quick recap of the personalities we've uncovered today. We've met the OH group, which gives us the helpful alcohol personality. We've got the COOH group, which gives us that sharp carboxylic acid personality. And we have the C equals O group, which, depending on its location, can give us either the end-of-the-line aldehyde or the in-the-middle ketone.
When you get right down to it, it all comes back to this one core idea. It's the functional group that decides everything. It's what gives a carbon compound its properties, and it does that no matter how long the carbon chain is. That little badge, it calls all the shots.
Which leaves us with a final, kind of mind-blowing thought. We've seen how just a few simple badges can create wildly different things. So could it be that the incredible diversity of millions of chemical compounds, the ones in our food, our medicines, our world, even in our own bodies, is really just an endless combination of a few basic personality badges, all snapped on to a simple carbon frame? It's an amazing, elegant idea to think about. Thanks for joining me.